Welcome back. In this video, we will learn about chemical bonding, and we'll focus on ionic bonding. We'll learn how to describe and recognize ionic versus covalent bonding, and then we'll also learn how to identify whether or not a compound is ionic or molecular. So up to this point, we've really just been talking about individual atoms, and now we're going to learn about what happens when those atoms combine. They can combine in two main ways. One is through ionic bonding. This is where the electrons of one atom are given to another element, and they form separate ions. So an ionic compound consists of positive and negative ions, cations, which are positively charged ions, and anions, which are negatively charged ions. This usually consists of a metal, which is the positively charged ion, and the nonmetal, which is the anion. Some examples include sodium fluoride, potassium sulfate, magnesium nitrate, and ammonium chloride. Now, when you take a look at these different examples, you'll see that the first three all have combinations of metals with nonmetals. Sodium is a metal, potassium is a metal, magnesium is a metal, and then fluoride is a nonmetal, sulfate consists only of nonmetals, and nitrate consists only of nonmetals. However, ammonium chloride consists of nonmetals entirely, and this is the one example that you need to be aware of. All ammonium compounds are ionic compounds, and that's because ammonium is a cation, and so it behaves like other metals do. We can also get covalent bonding. This occurs when the electrons are shared between different nuclei, and they form distinct molecules. So all molecular compounds consist of individual molecules, which you could separate from one another. And these are also consisting only of nonmetals or metalloids. So some examples are hydrochloric acid, water, acetic acid, and ammonia. All of these compounds consist only of nonmetals. As a reminder, when we talked about the periodic table before, we were able to classify the elements into metals, nonmetals, and metalloids. You can see here a reminder of what we've seen already. So when we form ionic compounds, these are going to consist of metals combined with nonmetals. And those nonmetals might be monoatomic, they might just be a single element, or they could be combinations of elements, what are called the polyatomic ions. For molecular compounds, again, these consist only of nonmetals or metalloids. We can get combinations of metals, and that forms metallic bonding, but that goes beyond the scope of this video and this course. So let's practice. Which of the following are ionic or molecular compounds? In order to answer this question, we need to identify what type of bonding we have, whether we have ionic bonding or covalent bonding. And in order to do that, we need to identify whether or not we have cations or anions. This first example illustrates an important exception. Normally, in order to have ionic bonding, we need to have metals with nonmetals. In the case of ammonium compounds, the ammonium behaves as a cation, and therefore it forms ionic bonds. So this is an ionic compound because we have ammonium ions and bromide ions. The second molecule, when you look at it, it consists entirely of nonmetals. Carbon, hydrogen, and nitrogen are all nonmetals. Therefore, this is a molecular compound. It's important to distinguish between ammonium and the other groups that contain nitrogen in them. Ammonium is going to have NH4 as its component. This third compound consists of hydrogen and chlorine. Those are both nonmetals, and therefore this is a molecular compound. We'll learn later that this is an acid, and all acids are molecular compounds. The next one, we have hydrogen with nitrogen and oxygen. These are all nonmetals. and so this is a molecular compound. The next one consists of bromine and chlorine. Again, these are both nonmetals, so this is a molecular compound. Finally, the last structure consists of xenon, oxygen, and fluorine, all three of which are nonmetals. Therefore, this is a molecular compound. So that's it for this video. Thanks for watching. Have a great day.